Hello everybody and welcome to the Reading Boys Mock A review. This is a review of paper 2, the mathematics paper. In this paper I'll be going through and providing worked examples for each of the questions in the maths exam. But please remember, when you're reviewing it yourself, I wouldn't necessarily expect you to have the exact same amount of working because there'll be some questions you'll have done in your head. However, for any questions that you've gotten wrong, or any questions that you weren't able to work out on the day or work out particularly efficiently, I'm showing you the model amount of working that I would expect if you were going to do working. Remember that with all these questions, working out is vitally important to getting an answer correct, but not at the expense of sort of speed and accuracy. So if you know you can do something in your head with good confidence, that's absolutely fine, and we encourage that because getting to the end of the questions, again, in a good order, with good accuracy, is really important. Right, having said that, let's jump into it.
There are obviously some practice questions here, and they're going to need 5 minutes to run through them. I will explain each of them because it's important you understand, but again, remember the practice question is more a chance for you to familiarise yourself with the paper, with how you want them to be filled in. Remember, you won't just be having this, you'll also be having an answer sheet or be recording your answers, so it's really important you check to make sure that your answers are being recorded in the correct way, and that's really what this time is for. Also, it's an opportunity, I suppose, if you do finish the practice questions nice and quickly, for you to go through and perhaps jot down or remember any mnemonics, think about things. So for example, if it was a non-verbal, I might jot out my SPANSROS, which is my acronym to help me remember there. Or if it was a maths, for example, I might, if I was always forgetting what the mean meant or the range was, I might jot those notes down as well. So don't be afraid to use this practice time, especially if it is sort of 5 minutes, which is quite significant. After you've answered the questions and thought about how you're going to record them, to think about other topics and other hints and tips that may well help you. Another one that I know that's really good is people who struggle with negatives will often write out a little sort of plus is a plus, minus and a minus is a plus, and then plus minus plus, both equal minuses. And that's a very easy way of now remembering what happens. So the combination of these results in this. And that's the kind of note you could easily make in this time, which I think is a nice little tip. So don't be afraid, really all I'm saying is don't be afraid to utilize that practice time as best as you can. Right, let's see. So here we've got 48 times 2. Well, in that case, I'm going to double 40 in my head, which is 80, double 8, which is 16, and then 80 plus 16 is 96. And I probably wouldn't even write this out. I'd go straight to the answer, but just to show you where it came from. That's what I've done. And again, I did that in my head to make it nice and easy. Number 2, I eat a quarter of the pizza and my friend eats half. How much is left? So you've had a quarter and a half. Written the half, so sorry, a quarter plus a half. Remember, when we're adding these together, I need to convert them. So if I want to visualize this better, I might think about a quarter. Do that again. A quarter plus 2 quarters, which is the same as a half. And that means 3 quarters has been eaten. And from here, I can see that if 3 quarters have been eaten, I'm going to need 1 quarter left over. So then the answer is definitely 1 quarter because it's going to add up to a whole amount, a whole pizza. But question 3, what is 10% of 606? I remember it's my favourite one, 10%. 10% is the only percentage where you divide by the same number. So to find 10%, you divide by 10, and that's nice and easy. So the answer is going to be 60.6. And again, if we're just talking about little tips while I'm doing it, when dividing or multiplying by 10, you're moving the decimal by the number of zeros. So in this case, you're dividing by 10, so the decimal is going to move up one space. So the decimal is going to move between as is found in the answer. So that's your practice question. Let's get into the main. So, number 1. What is 129 plus 253? That to me sounds like a column addition. So I do 253 plus 129. I always like the bigger number on top. It doesn't actually matter. And now 3 plus 9 is 12, so carry the 1. 5 plus 2 is 7, carry the 1 is 8. 2 and 1 makes 3, so 382 is our answer. What's the next number in the sequence? For this, I always like to list the difference between the two numbers because it helps me spot patterns. So between these two numbers, the difference is 11. 36 to 38 is 12. Then 48 to 61 is 13. And now I can really clearly see 11, 12, 13. So the next number I'm going to do is add 14. And 61 add 14 is 75. That's where my answer comes from. 396 out of 18, this is a division. For me, personally, this is what we tend to teach teachers. I like to just do short division for all division. because it trains really good mental maths and it's much faster. So let me show you what this would look like. So I would start by saying how many 18s go into 3. It will always be 0. You're never going to have a 2-digit number go into a 1-digit number. That's just not possible. But now I can carry the 3 over. Whether you write it like that or you do like a little smile to imply that the 3 is being carried over to 9. So now, how many 18s in 39? Well, 18s times 2 is 36, so it'll go in at least twice with a remainder of 3. So carry that 3 over. And again, as you said, 18s and 36 go 2 times, so remainder 2. And it's as simple as that. And that to me seems like the fastest method. What I would recommend is if you aren't sure, and especially if you're struggling, listing out the essentially what is the 18 times tables is a really nice way of ensuring this becomes fast, because you have to just list it out once. So we would keep going only as far as you'd need. So there you go, that's enough. And I can now see, yep, look, 18 goes into 39 twice, goes into 36 twice, job done. And even if you have to listed it down to, 6 or 7 times, you've done it once, then you can use that to really speed up your short bus stop process. Number 4, what is 25% of a fifth of 5,500? Interesting question. I think for this one, I'm going to start by working out what a fifth of 5,500 is first. So let me just translate that. This is what I mean by rewriting it in a slightly friendlier way. So that's 1/5 of 5,500. And now it looks like this. I'm going to find it a lot easier because I know with any fraction, I'm timesing by the top, dividing by the bottom, timesing by the numerator, dividing by the denominator. And times by 1 doesn't change it. And dividing by 5 is actually quite easy because 55 divided by 5 would be 11. If I add the zeros on, I'm going to get 1100. And now I can work out 25% of 1100. I'm trying to fit it in there without drawing on top of Billy. Now, 2 options here again. You can either just have learned that 25% is a quarter, so you can go back to do the fraction way. So one option would be to do 1/4 of 1100, and then times and divide. But I'm going to show you the other way, of course, because it's important I show you both ways so you can have the best chance. Let's move that over. The other way, of course, is just work it out as a percentage. And my recommendation for that, to work out 25%, would be to work out 10%, because 10% is the easiest percentage to work out. And then from 10%, you'll be able to work out 5%. And hopefully you can see that 2 10% and 1 5% will add up to make 25%. So 25% of 1100, well, 10% would be dividing by 10, so that's 110. 5% is going to be half of what 10% is, so half of that's going to be 550. And that then means to get to 25%, I'm going to need to add 110, another 110, and a 55. Again, I'm going to move it over because I'm running out of space. There, that works better. And that simplifies down to 110 plus 110 is 220, plus 55 is 275, which is my answer. And were I to divide 1100 by 4, I'd get the same answer. So either option works there. And again, I recommend probably sticking within the field that you're most comfortable with. So if you're really good at fractions, do fractions. If you're really good at percentages, work it out using percentages. Okay, let's scroll down a bit. Number 5, in the school long jump, Ranjit managed a jump of 2.5 meters. Clive managed 3/5 of that distance. How much further did Ranjit jump than Clive? So Ranjit did 2.5, Clive managed 3/5. So let's write out 3/5 of 2.5. This is going to look awfully familiar. Times by the top, divided by the bottom. Now, you can actually choose the order, and I think 2.5 divided by 5 is actually easier because 25 divided by 5 is 5, so 2.5 divided by 5 is going to be 0.5. So all I've got to then do is work out the leftover, which is 3 times 0.5, which is actually the same thing as 1.5. And that's a bit of pre-planning, just spotting that. But again, if I was to do it the other way and I was to do 3 times 2.5, that's 7.5. And if I do 7.5 divided by 5, that's the same as 75 being divided by 5 is 15. So 7.5 divided by 5 is 1.5. So it works the same way, but just know that you can choose to do it in order that you find easiest, and that can often speed you up again. Number 6. What is 74.38 plus 19.64? Again, this will just be a column addition. So 74.38. Just going to make sure everything stays in the same columns, the same place values, plus 19.67. Then we've got 8 plus 7 is 15, so carry the 1. We've got 3 and 6 is 9, but plus the one we carried is 10. Put the decimal in the same place. 4, well, I've had 9 plus 1 is 10, plus 4 is 14, so 1. And then 7 and 1 is 8, plus the 1 is 9. So 9405, 9405. And again, if you want to add the line in, you're more than welcome to make it look more like your column. That's no problem. Number 7. Robert left his house at 11:45 and returned 2 hours and 20 minutes later. What time did he return to his house? So again, I like to always break these questions up and deal with them in parts. So 11 plus 2 hours is going from 11, 12 to 1. So it's 1:34 will be after we've added the 2 hours. Added the 2 hours. Now we've got to deal with the minutes. Now, unfortunately, this is going to tick over into the next hour, so I'm going to ask myself, how many minutes from 34 to 60 do I need? Well, that's going to be, if I have 26 hours, 26 minutes, that's going to take me to the next hour, so that's going to get me to 2 o'clock. And then the leftover from 26 and 28 is 2, so I've still got to add an additional 2 minutes, which is going to go to 2:02. Now, a lot of that you could probably do in your head, but I do recommend with date and time, where the units are slightly different, or it's not the units, but it doesn't add up to multiples of 100. Instead, we're going to the next hour after every 60, or in the case of a day, after every 24 hours, things like that. It's a lot easier to just do it in parts. So deal with the hours first, and then deal with the minutes, and then just think about what's left over. That's probably the fastest way. And of course, make sure you have the PM, because it does say AM, so this is, of course, got to be PM. Number 8. What is 3 to the power of 3 times 7 to the power of 2? Another way of saying that is what is 3 cubed times 7 squared? So with these, I'm going to split it up into its components. So I'm going to first off work out what is 3 times 3 times 3, because that is what 3 cubed means. And then I'm going to work out what 7 squared is, which is 7 times 7. 7 times 7 I can do most easily, so let's get that out of the way. That's 49. 3 times 3 is 9, and 9 times 3 is 27. So now what this question has really become is 49 times 27. And the way I would do that is either to use column multiplication or to use the lattice method. I'm going to show you the lattice method because I think most people are more familiar with the column, and it's always nice to have new methods. So the lattice method, also known as the Chinese grid method, and it's got all sorts of names, involves you creating a grid and having a number aligned along each of the columns or the rows. And all you do is as follows. So 2 times 4 is 8. So that's 0 tens, 8 units. You've then got 7 times 4, which is 28. So that's 2 tens and 8 units. We've got 7 times 9. If you find your 9 times tables hard, just do 7 times 10, which is 70. Take away 7 to go back to the 9 units, which is 63. Quite a nifty way of doing it. And 2 times 9 I can handle, that's 18. Again, 1, 10, 8 units. And now, do you see we added in these sort of horizontal columns? If you just add up down the columns, you'll get your answer. So we have here just a 3. 8 plus 8 is 16, plus 2 is 22, so we carry the 2 and write the 2. We then got 8 plus 2 is 10, plus the 1 is 11, plus the 2 is 13, so again, 1 and the 3, and then 0 plus 1 is 1. So the answer is now read from left to right, so 1, 3, 2, 3, 1, 3, 2, 3. So there's the lattice method, and that's quite a nice sort of foolproof way of doing it. I like it because it works really well with decimals as well. But again, if you like your column method, by all means do the column method as well. I know there's loads of videos out there. I'm sure one may even come up later, we'll have to see. So number 9, a group of pupils were asked which subjects they liked and record them in the pie chart. 150 pupils said English, so that means 33% is representative of 150 students. And it says how many like maths? Well, let's work out what percentage are maths. So if all the other percentages add up to something, whatever's left must be the difference between these guys and 100, because we know that all of something is 100%. So 22 plus 33 is 55. 55 plus 34 is 89. So I know that all of these guys add up to 89%. So the remaining bit must be 100 minus 89, which is 11. So the maths is 11% of the students. And if 30% is equal to 150, I can actually see a really nifty way straight away of working out what 11% is, because to go from here to here, it's just 3 times less, which means this is going to be 3 times less as well. So 100 divided by 3 equals 50. So 11% of the student body is 50 students, which means 50 students like maths. Final answer. That's quite nice. Good question. Number 10. 3 pieces of luggage weigh 7.2 kilograms, 805 grams, and 396 grams. How much do they weigh in total? So whenever I see one of these questions, I have 2 rules that come into my mind. First is get all the units the same. I often do that at the start before I even start adding them. And the other clue is look towards the answer to see if there's a clue. So in this case, since the answer wants it in kilograms, I might convert everything to be kilograms. Although I could equally see the argument of converting everything to grams first, because then you have to deal with any pesky decimals. So you can choose here. And you know what? Because 2 of these are in grams, maybe I will just convert this one over. So that's going to leave me with 7.2 kilograms is 7,200 grams, which I then have to add 805 and 396 to. So 7200. Let's move this out of the way so I don't draw on poor Billy. Plus 805 plus 396. 0 plus 5 plus 6 is 11. 9 plus 1 is 10. So carry the 1, write the 0. 8 plus 2 and 3 plus 1 is 4. And 7 plus 1 is 8. 7 plus 1 is 8, not 1. So 8401, remembering that that's in grams, so if I need to convert it to kilograms, I divide by 1,000. And this is a really good thing to learn, guys and girls, is all your conversions. But my recommendation for conversions, just very, very briefly, is to learn what the prefixes mean. So kilo is 1,000, milli is 1,000, centi is 100, and what other examples can I think of? Oh well, we said milli, centi, kilo, and then if it's just no prefix, just the meter, then that's one. And I would make sure you know how many, or the difference between those conversions. For example, how to get from centi to milli. So that's actually a difference of 10. The reason is because it's a difference between 100 and 1,000, and that's 10 times bigger than the other. But it's worth learning the prefixes because then you can apply them to everything. So it doesn't matter if it's kilograms or kiloliters or kilometers. You still know that going from kilo to the base grams or kiloliters to the base liters is still 1,000. So learning those prefixes will save you a lot of time because they are then applied to everything. So very quickly, sorry, just to finish, 8401 divided by 1,000 gives you 8.401 kilograms, which is the answer. Number 11, a square has a width of 15 centimeters. What's the area of the square? So this is just a quick fact. We need to know that the definition of a square is that all the sides are the same. So if one has a width of 15, it also has a height of 15. And now that means the area of the square will be these two multiplied together. And 15 times 15 equals 225. It's possible you may have learned that, because actually I must say I do recommend to my students that you learn your square numbers as high as 15 times 15. So you know what 9 times 9 is, 10 times 10, 11 times 11, 12 times 12, 13 times 13, 14 times 14, and 15 times 15. And that would be really useful. Again, if not, otherwise you can maybe set yourself out a nice simple column multiplication. And I'll do a multiplication this way just to show you, because I used the lattice method last time. So for these, just make sure you set it out nicely. So 5 times 5 is 25. 5 times 1 is 5 plus 2 is 7. You've then got not 1 times 5, but 10 times 5. So 10, because that 1 is in the tens column. So it's 10 times 5, which is 50. And then 10 times 10, which is 100. And now you've got your two numbers. I always have to do another line. Again, I'm going to add these two together. 150 plus 75 equals 225. So that'll be an example of how you set it out. Again, just remember that notice how I said it. I didn't say 1 times 1, I said 10 times 10, and that then gives me the answer and tells me in what column to put it in. It's really good, really useful way to think about it. Number 12. I'm thinking of a number, I treble it, and that means times it by itself 3 times. Doubling is 2, while trebling is 3. I add 49, then I halve it. I end up with 50. So what number am I thinking of? Well, in this case, I just have to do the reverse. So if you started with 50, The opposite of halving it is doubling it, so that's timesing by 2, which is 100. I then add 49, so the opposite of that is take 49. So if I do 100, take away 49. If I didn't divide, I meant to do take away, excuse me. Take 49 equals 51. And then finally, the opposite of trebling it, which is timesing by, so 3 or times by 3, is dividing by 3. So 51 divided by 3 equals 17. And so in that case, you just have to remember whenever you get these sort of sequences and you're doing the reverse, to remember to do the opposite, including, so the opposite of timesing by 2, opposite of minusing is plusing, the opposite of dividing is timesing, and so on. So you just want to remember what these words mean. Number 7, a cube is 7 centimeters high. So this is a very similar question as before, except now we need to know what a cube is defined as. And it's very similar to a square, except it's a 3D version. So it's a square in 3D. And what this means is if one length is 7, the height and the width are all also 7. So I need to have 7, 7, 7. And then I can now work out the surface areas. So since all the surfaces are going to be the same because they all have the same measurements, if I work out the area of one of those shapes, which will be 7 times 7, which is 49, I now know what all of them are because they're all the same because it's a cube. So I can now just do 49 multiplied by, which is the area of one square, multiplied by 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So you can see counting the different dots. And this is really useful to be able to draw yourself a little diagram in that. So 49 multiplied by 6, give me my answer. In this case, 49 multiplied by 6 is 294. And again, put it in your method of choice. And just remember, centimetres squared would be the units if you had a chance to put the units down, because it's a measure of area, and area is always in units squared. 14, which is the highest of these numbers. So all I need to consider, the largest is, look at the first, so they all start with a 3. But the next one is 2, so that's winning. 0, no, 0, no, 2, no, 3. This number here. And again, really, all of the skill, all I'm doing is just imagining that would read 3,301 compared to 3,291 compared to 3,299. Obviously, the 3,300 would be higher than the 3,200. Now, that's not what the number is. It's 0.3, but the idea remains the same. You're always looking at the leading number first. So there's my answer to number 14. Quite an easy question, that. Number 15. What's the size of the smallest angle between two hands of the clock at 3:30? This is a great question. It's certainly one that I'd recommend sort of sketching out. So again, draw yourself a nice neat circle. And then sketch on some numbers. So I think for this one, 3:30, we're going to need to know where 3 o'clock is, 4 o'clock is, 5 o'clock is, and 6 o'clock. I don't think we'll need any more than that, but if we do, we can always add them on. So let's just mark it. Let's do it. Again, it's only a sketch, and I'm obviously using the tools to make it look nice, but I wouldn't expect this to be more accurate. It's just more to help you. So if it's 3:30, one hand is pointing then down at the half an hour point, and if it's 3:30, the small hand is going to be pointing between the 3 and the 4, like that. I'll just add a little mark on. So, what are we going to need to know to answer this question? Well, ideally, I would want to know how many degrees are between each hour, because I've then got 2 hours, and if this hand is halfway between 3 and 4, it's going to be a bit like sort of 2.5, whatever the value of 1 degrees is. So how can we work out the number of degrees represented by 1 hour? Well, if we think about it, it's 360 degrees is going to be the whole circle. We know a clock like this is split into 12 hours, so if we divide 360 by 12, that's going to tell us the number of degrees for 1 hour, and that's 30 degrees. This is also something I've actually recommended to people they learn in the past. Now, obviously, it's not too bad of a sum to do, but it's a nice thing to know that on a clock face, 30 degrees is 1 hour. And we partly do that just so that you can sort of estimate in your mind. If I said, 40 degrees, you'll know, oh, that's a bit larger than the gap between 1 and 2 on a clock face. So it's a nice thing to just have in your mind, this fact. Now that we know, however, it becomes nice and easy on our sketch. We can say, well, then it's going to be 1 hour, so it's going to be 1:30, another hour, another 30. And if it's halfway between 3 and 4, it's going to be half of that. So half of 30 is 15 degrees. And if I then add up 30 degrees, 30 degrees, and 15 degrees, I get a total of 75 degrees, which is the correct answer. So again, possibly a quick sketch may help you out there. Again, just night, it should needs to be just simple. It lets you think about the hours. This key fact that you either remember or now know how to work out the number of degrees represented by 1 hour, and then you can solve your answer without issue, without problem. Number 6. Robert is saving to buy the newest console. It's £495 and he's saved £185 so far. However, the console is being reduced in the sale by 20%. How much more money will he need to save in order to buy the console? So the first thing is, let's work out what the new price is. So that's involving these two. Again, notice how I'm going to highlight the two numbers I'm working with. So if the price has been reduced by 20%, I need to know what 20% of 495% is. And as I've said every single time, the way I'm going to do that is probably by working out what 10% is. 10% is going to be dividing by 10, so it's going to be £49.5. And if I know that that's what 10% is, 20% hopefully I can work out is going to be twice as much. So if I double 49.5, I'll get my answer. For this one, you may also double 50 and take away 1, whatever's easiest. Again, I think it's something that you can probably do in your head. So it's £99 is the answer. But again, you could do 49 plus 49, which is going to be 98, plus 0.5 plus 0.5, which is a total of 1 to get to 99. There's a lot of ways of sort of breaking that apart. So it then means it's being reduced by £99. So what this means is we've got to reduce this amount by 99. So we can do 495, subtract 99, and this will tell us the new cost. Obviously, you can't do 5 take away 9, so you've got to carry the 1, so that becomes an 8, and that becomes a 15, so you have a 6. You can't do the 8, so it carries, so that becomes a 3, that becomes 18, 9, 3. So the new cost of the console is £396. And then if he had £185 so far, we again want to know the difference between what he's got and what he needs. So now we have to do 396. Take away 185. I'm going to see this is going to be a bit easier with less carrying. 6 take away 5 is 1. 9 take away 8 is 1. 3 take away 1 is 2. So the answer is £211 remaining. And hopefully you can see that wasn't too much working out for me to do. I broke it up into steps, and that made it a lot easier. And again, I recommend try and treat it in step by step by step, break it up into little parts, and you'll keep making progress. Number 17. The gaps in the sequence are increasing by 5 each time. Cool, that's useful to know. And then find the value of y, this one, minus this one. So first thing, I want to know what y is and what x is, and then I can work out what they are taking away from each other. So the gaps in the sequence are increasing. So again, whenever I see a sequence question like this, I want to immediately work out and write down the difference. So 46 take away 31 is 15. And so if they're increasing by each one, I might just check the next one. Let me see, this one should be going up by 20. Yeah, look, 46 to 66 is an increase of 20. So this next one must be an increase of 25. So what then will the increases be? So that means this increase is an increase of 10, and this is an increase of 5. So now that I've got these facts written out, I can work out what the numbers are. So 31, going back to the last number, should be 21. So y needs to be 21, because it's 31 take away 10. And if there's a gap between 5, between x and y, 21 take away 5 is going to be 16. So those are my answers. And if I'm then doing 21 take away 6 to find the difference, sorry, not 6, take away 16, that again is going to give me a value of 5. And to be fair, we could have worked it out because it basically says the gaps between the sequence are increasing by 5, and we wrote here that the gap, the difference was 5. So actually, yeah, we pretty much solved that. Good. So the answer is 5. So again, the tips of sequences, write the difference at the top, so it lets you work things out. List what you need. So again, that's my value of y, that's my value of x, and then you're away. 18. In the horse race, Blossom the Wonder Horse ran for 4 minutes at an average speed of 30 miles an hour. How far did she run? Well, 30 miles per hour would mean she did 30 miles in 1 hour, which is the same as 60 minutes. So hopefully you're happy that I can write 30 miles in 60 minutes. So hopefully you can see there that statement is based on the fact that 30 miles per hour is what that means. So now I want to know how many miles could she do in 4 minutes. So all I have to work out is what the difference between 60 and 4 is. And just write min like miles. And remember, I can't just say subtract. It's not that. It's not that kind of ratio. This is like a sort of ratio question, really. So it's either a multiplicative or a dividing ratio. And in this case, to get from 60 to 4, I know that if I divide 60 by 15, I end up with 4. So I know that this value is 15 times less than this value. And the same is going to be true here. So if I divide 30 also by 15, that's going to give me an answer of 2. So to fill it in, how many miles in 4 minutes? She would have gone 2 miles in 4 minutes. And I think this is by far the simplest way of setting out that style of question. So you see there, the answer is 2 miles. 19. Susie and her mother are making up party bags for her birthday party. For every 3 stickers they put in each bag, they put 5 lollipops. They make up 24 bags in total, with the same amount of stickers and lollipops in each bag. If one bag has 40 lollipops, how many stickers are there across the total of all bags? My goodness. So this is the kind of question that's quite confusing, and it's confusingly written, so you have to break it down into steps. So first fact, they tell us for every 3 stickers, there are 5 lollipops. So this is a ratio of 3 to 5. So I'd write that out. We're going to notice I've got an S and L for stickers and lollipops to keep things quick, but also to keep things clear. So they make up 24 bags in total. So again, I'm just focusing on that bit to say. So at some point, I'm going to have to times something or other by 24 to work out the number of times. They then go on to say, if one bag has 40 lollipops, so we know they're put in this ratio, and we now know that the bags have got 40 lollipops in them. If one bag has 40 lollipops, then how many other stickers are there in total? Okay, so I see how to link it now. So what we're going to say is the difference from 5 to 40 is times by 8. So this base ratio, we've got 8 times more. Because it's a ratio, that means there are also going to be 8 times as many stickers as 3 times 8. Because if the 5 increases by 8, so will the 3. So that means there are 20. So in each one single bag, there are 24 stickers. And I would even maybe write 24 per bag. So then go back to the question. They make 24 bags in total, and it then says how many stickers are there in total across all the bags. So if there's 24 stickers per bag and 24 bags, that now means we have to do 24 multiplied by 24. And again, I know there's plenty of ways to do this. I'm going to show you another one just for fun. So you could do 20 times 20, and maybe even do that in your head. So 20 times 20 is 400. And then you can do 4 times 4, which is 16. And then you can do 20 times 4, which is 80, and 20 times the other 4, which is 80. So that's like cross multiplying all the components. If we add these together, you can do 400 plus 16 plus 80 plus 80, which takes us to a grand total of 576. So that's another way of doing these multiplications ahead. But again, although I've showed you now 3 different variations, the reason I do that is because I want you to know that you can see your version being done. Excuse me, so 576. But always use your strongest multiplication. So if you're really good at the column method, use that. If you're really good at the lattice method, use that. If you're really good at mental maths and you get it right with great accuracy, use that. But use the method that works best for yourself. Question 20. Add 437 to 89. Nice and simple. 7 plus 9 is 16, so 1 and 6. And then 3 plus 18, so 3 plus 4, so 12, that's 1 and 2. And then 4 carry the 1, or add the 1 is 5. So 526 is my answer. I'll underline that better. Jolly good. 21. The width of the square in centimetres is 9y, where y equals 4. What's the perimeter of the square? Oh, okay. So again, it's a square. I like to draw myself a diagram as soon as I get given any kind of shape. So the width of the square is 9y. Here. But it tells me that y equals 4. So I can do a substitution here and say that then it's 9. And notice not 94, but 9 times 4. And that's using my rules of algebra. Whenever I see a number and a letter next to each other, I know there's a secret times sign between them. So 9 times 4 I can work out. Remember the trick, so 10 times 4 is 40, take away 4 is 36. That's a good way of doing your 9 times tables. So the width of each square is 36. What's the perimeter? Well, if all of these, 1, 2, 3, 4, go on as a 36, that's going to be the same as 36 times 4, or 36 plus 36 plus 36 plus 36. And a nifty little trick for timesing by 4 in your head is to double and double again. So 36 times 2 is 72, and 72 times 2 is going to be 144. So that's how I would probably solve that in my head. 22. I am looking at a hexagon. Let's draw that. Hexagon is a 6-sided shape. You need to know the names of all your shapes. An equilateral triangle and a pentagon. Oh, more shapes to do. Should have kept going. So there's an equilateral triangle. Here's a pentagon. How many lines of symmetry do these shapes have in total? Well, that's 1, 2, 3 lines of symmetry. 1, 2, 3, 4, 5 lines of symmetry. And 1, 2, 3, 4, 5, and 6. Not quite sure I've got arrowheads. 6 lines of symmetry. So that's going to be 6 plus 3 plus 5, which is 14. Again, just I'm not sure, depending on how good your knowledge is, you might not need to sketch them. Certainly, I wouldn't have thought you need to sketch an equilateral triangle. But again, doing a little sketch and just seeing lines of symmetry can help visualize it. I'll tuck that little one back in. Yeah, I'm not sure why these are headed arrows. Let's get rid of those heads. It's better. Makes it a bit cleaner. That's how you solve those. Nice and easy. Number 23, what's the perimeter of the shape? So the perimeter is the outside, so I'm obviously missing a key fact across here. Luckily, if the whole thing is 40 and that's 15, I know that this is going to be here 40 minus 15, which in this case is 25. I then need to work out the other side, so let's mark that as well. Let's put that in nice blue. So this is the other side here that's missing across the way, from top to bottom. And again, we work that out the same way. If the whole thing is 12 and this constitutes 5, this must be the difference between the two. So I can do here in blue. Oh, change my color. So this here in blue. Go to 12 minus 5, which is 7. So now I've got all my measurements. I can add them all together. And plenty of ways of doing this. I think for me, the easiest way is going to do 15 and 5 is 20. Then 20 plus 40 down here is going to be 60. I can handle that, not too bad. Ooh, then plus probably 25 is next easiest. That gets us to 85. Then 85 plus 12, that's like adding 10, then adding 2, which is 97. And then 97 plus 7 gets us to 104. But again, if you couldn't do that mentally in your head, not a problem. Just list it out as you need and you'll get your answer. What's the area of the shape in question 23? Okay, well, the way I do this is compound shape. So let's do this area one in red. I think that seems a good idea, so it stands out. So for that, all we have to do is split it into 2 sections. So I'm going to choose to split it across here. It wouldn't be wrong to split it that way, but this is the one that looks best to me. And that then means I'm going to be able to work out the area of this shape here, and then the area of the whole shape here, and then whatever those 2 areas are, add them together. So in this one here, it's going to be 15 times by 5, because it's the height times the width. And this one here, again, height times width. Remember, this is not the width of the red section. It's the 40 is the width of the whole thing. So for here, it's going to be this height here, which is the height of 12, multiplied by this here, which is a length or a width of 25. So those are the 2 sums I need to work out. 15 times by 5 is not so bad. That's 75. That's one you may have learned. If not, again, you could work out. And then 12 times 25, a little bit harder. You may, if you wanted to, choose to write it out as a sort of column of some sort or lattice. But actually, I think for this one, I know that 4 lots of 25 is 100, and 12 is 3 lots of 4, so it's going to be 3 lots of 100, making it 300. So actually, that's not the worst one to be able to work in your head. And then if you know this one's 75 and this one's 300, add them together. and you get your answer of 375. Again, remembering units, centimeters squared. 25. Some friends went to the local cafe and bought 4 coffees and 3 teas for £5. Some other friends bought 2 coffees and 3 teas for £3.40. How much is 1 coffee in the cafe? Okay, so I'm going to write this nice and clearly. So 4 coffees plus 3 teas equals £5. And 2 coffees and 3 teas equals £3.40. So what this tells us is that the difference in the price is because of the difference in the amount of coffees. Can you see that? Because the teas here are the same. So if we take these values away from each other, so if I do 4 coffees, take away 2 coffees, that leaves me with 2 coffees. 3 teas, take away 3 teas equals no teas, which will be equal to £5 take away £3.40. £5 take away £3.40 is £1.60. So that means the 2 coffees are responsible for the difference in price between these, which is £1.60. So that means 1 coffee is going to be half of £1.60, which is 80p. And that's our answer. So the cost of 1 coffee, or C, or 1C, however you like to write it, is down to the 80p. Okay. Next. This one, 26, up the top here. Calculate 2/5 plus 3/7. 2/5 plus 3/7. Really important you know how to do this. The rule is you can only add fractions when the denominators are the same. So the first thing I'm going to immediately do is rewrite this in a format where the denominators are the same. The easiest way to find a common denominator is just to do 5 times 7. 5 times 7 is 35. So I know I can multiply both of these numbers by something to turn them into a fraction. That's out to 35. 5 times 7 is 35, so to keep the fraction the same, I have to do 2 times 7, that's 14. And then 7 times 5 is 35, so I have to do 3 times 5, which is 15. Once the denominator is the same, you can just add the fraction, keeping the denominator as is, and then just add the numbers on top, so it becomes 29 over 35. Really important you're comfortable with that, and that's the answer, nice and quick. Let's move that around a bit. So look at the straight line drawn below. What are the coordinates of A? So, few things you can do here. I think the easiest way is probably just to map out the change onto this triangle. What do I mean by that? Well, if we look here, the difference in this x value is going to be the difference between this coordinate and this coordinate. So it's gone from 0 to 1. So it's moved 1 over. And in the time that it's moved 1 over, it's gone from being 6 high to 4 high. So it's gone down by 2. So hopefully you can see it's gone 1 left and right, 2 up and down. If we then follow that pattern down, so we're currently at 4, and we know A is going to be at the point, or the height of 0, because it's on this axis at the bottom here, it's on this x-axis. If I go down another 2, across another, I should use my pen for drawing, so down another 1, across another 2, we're going to end up here, and that's going to have a coordinate. I've probably not drawn it to scale very well, I have to admit. That's going to have a coordinate of, it's not 0, sorry, -1, 2. And I know that because it's gone down from 4 minus 2 to 2, and it's gone from 0 to -1. And if I then go down and across again, I'm going to go down again by another 2 and across by -1, so the coordinate's going to be -2, 0. And again, I know I'm aiming for this 0 because I know that A has to have this height coordinate of 0 along this axis here, the y-axis, because it's not possible to be on the x-axis, to be on this base level here without being at 0. Again, maybe that needs to be a bit higher, possibly, just to make it look to sort of to scale, but hopefully you can still see the idea that I'm just applying the change down, almost like a step ladder, walking down to get to my base. Number 28. Paula has 3 times as many toys as Graham, who has twice as many as Lucy. They have 126 toys between them. So how many does Paula have? So Paula has 3 lots of Graham, and he has twice of Lucy. So I'm going to say Lucy to start. So I've got Paula, Graham and Lucy. And the secret of these questions is always to find the starting person. And what do I mean? I mean the person who just has an amount. And in this case, Paula has 3 times, Graham has twice as many, which means Lucy is our starter. So I'm going to call Lucy X. And the reason I've done this is because Lucy's the one who's not relied on things, so she's just got the basic amount. Graham then has twice as many as Lucy, and because I've called Lucy X, I can now say, well, that means Graham is going to have 2 lots of that, so he's going to have 2x. And then finally, Paula has 3 times as many as Graham. Well, if Graham has 2x and she's 3 times as much, that's going to be 6x. Because I'm timesing this by 3, and to go from here, I was timesing it by 2. They now say they all together have 126 toys, so it means all of these values added up equals 126. That's going to look like 6x plus 2x plus x, which is going to be 6, 7, 8, 9. So 9 lots of x equals 126. And if 9 lots of something equals 126, x is going to be equal to 126 divided by 9. And again, I would probably just use a good old-fashioned bus stop. 9s into 1 don't go. 9s into 12 go once, remainder 3. 9s into 36 go 4 times. So that means x is going to be a value of 14. And then the question asked, how many does Paula have? Well, if Paula has 6 lots of x, she's going to have 6 multiplied by 14, 6 lots of 14, which in this case equals 84. And again, an easy way of doing that, you might do 14 times by 2, then times by 3. That's sort of splitting it up into easy stages that you can probably handle. Or again, if you're not sure, listing out your column method or any other method that you prefer will get you there. Right, guys, doing really well, nearly there now. So number 9, the carpenters are building a wooden ramp. They need a big piece of wood that can be cut into 12 equal parts. If each part had to be 128 centimeters long, what length would the wood need to be in meters? So it's going to be 12 multiplied by 128. Again, sort of use the method of your choice here. I think that's the easiest way of doing that. That's going to be 1,536. And then that's going to be in centimeters. So all you've got to remember is to go from meters to centimeters. That's a change from meter centi, like century, is 100. And my preferred method actually for doing these units, I will just quickly spend some time because it's important. If you can just remember that meters and centimeters has a gap of 100, now you can just ask yourself which number is supposed to be bigger. If a meter's larger, 1 meter would be the same as 100 smaller centimeters. So then you can work out that going in this direction you times by 100 and going in the reverse you divide by 100. So always just double check, so I call it a little logic check. Always have a think and just ask myself, okay, have I gone the right way? Have I times or divided by the right amount? And in this case we can see that it's in centimeters going to meters, so going this way we want it to go 100 times smaller. So 1,536 divided by 100. 2 zeros, so moves this in place 2 spaces over, 15.36 meters. Nice and easy. And again, for this multiplication, just use the method you're most comfortable with. 30. How many pairs of parallel sides does a regular octagon have? Again, this is where a handy little sketch will help out. So if you look here, this is a pair 1, this is a pair 2, this is a pair 3, this is a pair 4. So 4 pairs of parallel sides. 31. Which regular polygon is made up of 6 identical triangles? That's another fancy way of saying 6 equilateral triangles. And the answer here is a hexagon. And again, I would probably be sort of sketching this, but just to show you, if you divide it up, let's not do, why are you doing an arrow? Go away, arrow. I want a nice, simple, straight line, please. If I divide it from corner to corner, you'll hopefully notice here I've got 1, 2, 3, 4, 5, 6 perfectly equal triangles. So a regular hexagon is made up of 6 equilateral triangles. 32. What is 6 to the power of 3 minus 3 cubed? So again, this is an absolutely must for translating. So 6 to the power of 3 minus 3 cubed. So again, I need to remember that cubed, funnily enough, means the same thing. So it's this. And again, I would split this. So for example, 6 to the power of 3 is the same as saying 6 times 6 times 6, and 3 times 3 times 3. So actually earlier in the paper we worked out this. So 3 times 3 is 9, 9 times 3 is 27. 6 times 6 is 36. 36 times 6 you may want to work out in a calculator unless you've learned your cube numbers, which is fantastic if you have. The answer is 216. You can learn your cube numbers. I would normally say learning your cube numbers up to 5 or 6 is about right. Probably learning more than that might be slightly more effort than it's worth. In this case, I'll just work them out. But remember, to work this out, again, all I would do is I'd break it up into sections. So this bit here is 36 times by 6. And 36 times by 6 will also equal 216. So you can do that again using your preferred method. So now I've got what my values are. I can do 216. So this is the same as saying 216 minus 27. And you can possibly do that in your head, or you can do it using column subtraction, for example. But 206 minus 127 is 189. And so that is our answer. That's probably the fastest way of doing it. Again, notice if you do have something like this and you complicate and you need to work it out away from the question and then bring your answers back in so you have a nice flow so it all makes sense and you don't get confused. In a sequence, pattern A is made up of 16 squares, pattern B is made up of 25 squares, and pattern C is made up of 36 squares. How many squares would it take to make pattern F? Well, if I just list these numbers, 16, 25, 36, you'll hopefully start to see a pattern developing. These are our square numbers. And if I then label, so if I write above, look, A, B, C, D, E, and F, hopefully that's all the hint you'd need to be able to work this one out. So 16, 25, 36, that's 6. So 4 times 4, 5 times 5, 6 times 6, 7 times 7 is 49. 8 times 8 is 64. 9 times 9, ding, 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 is 81. And here's our answer, because that's pattern F. And I think really it's as simple as that, just recognizing the pattern, which is quite a cool question. Actually, I like that one. It's an interesting way of getting you to recognize these patterns. Number 34 is just good old-fashioned BIDMAS. So the rule is we do brackets first. So I'm just going to keep iteratively doing this question little by little. So here I've got the brackets first. So 4 times 7, that's in the brackets. And B for BIDMAS comes first. So I'm going to rewrite this as 94 divided by 28 divided by 2. And now it's going to be far easier for me to work out the division by 2. So I'm going to do 94. Excuse me, I think that's a plus. And that's a plus there, isn't it? Yeah, it is. So I'm going to change that to a plus. But in this case, make it even easier because, of course, divide comes before add and subtract. And our BIDMAS, again, we should write out BIDMAS. So for this one, we've done the B. We're now doing the division, and then we'll do the subtraction last. I'll show you the addition and subtraction last. So 28 divided by 2 is going to be 14. So it's then going to be 94 plus 14, which equals 108. So really, the only thing holding you back from this question was, do you know BIDMAS or BODMAS? Indices and order mean the same thing. So don't mind which of those you use. 35, last question. You've done really well, everyone. Thank you so much for your attention today. In 2019, Carol's flat was worth £1,200. No, sorry, £1,200. £120,000. In 2020, it decreased by 10%, and then she received an offer of 90% of the value. What was the offer? So first off, it decreased by 10%. So let's do 120,000. 10%, as we've talked about many a times, it's going to be dividing by 10, so that's like crossing off a 0. So that's going to be, or dividing by 10, which is like crossing off a 0, I should say. Just going to £12,000. So if it's lost that value, if it's decreased by that, we need to do 12,000 minus 12, which is going to be £108,000. And then if that's its value and she gets an offer of 90%, we want to know what that 90% is. Well, that's like 90% is like losing another 10%, isn't it? So if they've knocked off 10% of the value, they've knocked off 10% of 108, in this case 10% of this value. It's always 10% of what? So it's 10% of this was 12,000. So 10% of this value is going to be, poor cow, £10,800 less. So then we have to subtract from this, and this one might be worth writing out. Subtract 10,800. So there's the subtraction, and cross them out. Carry the 1. Sorry, no. 7, then you carry the 1. So there's your 2, these become hundreds. 7 taking nothing is 7. 0 taking 1 I can't do, so I have to borrow from there. 10 becomes 9. So £9,720 is my answer. Add the pounds back in. So I think the hard part there really was just realizing perhaps this 90% of the value question, where again, if she received an offer, so if someone said, I'll give you 90% of the value, again, they've taken off another 10%. So it's just really disguising the fact that they're asking you to take it off 10% and then take off another 10% again of the new price. So that's quite a cool question and really tests your sort of understanding of the vocabulary there. Right, everyone. Congratulations, you've made it to the end. Thank you so much for your attention. That was really good. If you have any questions, of course, don't hesitate to get in touch. But hopefully that'll explain to you sort of how to solve most of those questions in a nice way. And I really hope it obviously helps you in preparation for your exam. Right, everyone, that's us from Teach Right. Thank you so much for your time, and we'll see you again.